Okay, welcome back, champions. It's been a real honor in training you guys. You guys are quite passionate and you guys have that ambition of learning, and I must congratulate you once again for coming so forward and for coming so far in Python, right? And today we are going to start with filter and lambda expressions. Both are inbuilt functions of Python. But before that, we still have to take a look at what we learned yesterday. We'll have a quick recap and then start with the new things, right? Okay. Three different things. I'll just give you the quick recap. Have patience. But yeah, you need to have three things, right? One, we learned with open. Right, earlier we used to only work with open, right, file name and read or write whatever you had to do. Sorry, but yeah, now what we did yesterday, we learned that we can place this with before open, and then this, what it does, it is going to close down the file automatically. You don't have to close the moment the expression is finished running, so the file will automatically close. The second thing we learned was zip, right? And I told you about zip, right? What is zip? Zip is an inbuilt function. It iterates over multiple iterables. Now, what are multiple iterables? Multiple iterables are like dictionaries. We have sets, we have lists, we have tuples. They are all multiple iterables. So now, if you want to iterate over multiple iterables at the same time, we use zip, right? And it returns. Now, what does zip return? I told you to remember these questions for examination purposes. Zip returns tuple, right? So zip returns tuple containing the ith, or we can say nth or the ith element, which is basically when you loop through, you get the ith element or the nth element, whatever you call it. So zip returns tuple. And it basically it's for iteration, right? And yeah, now the second thing is we saw the demo. For demo, you can visit the previous video. And second was map. This is what we saw yesterday. Map, as I said, applies to, right, or applies a function to every element. So I'll say so it applies a function to every element, right, of input iterables. Now you can have two iterables that you want to send to function that you can use with map, and I've shown you the demonstration of this while we had that for some function defined, and we had to send list of things to to the function, so that the function returns the sum of two numbers. So for that demonstration, you can visit the previous video. And right, and now we have maps continued. So today we'll start with map, and I'll say map continued, right? So now let's see some more things about map, right? Okay, let me go to the spider now. Now we have spider here. Alright, so I can immediately go to spider, and I have commented down many, or I guess majority of things. So let them be in comments, so that maybe I'll make sooner or later I'll try and make a file out of it, right? Okay, now let's try and make a file, or we can say a map of cities, right? So I'll say names is equal to, it's going to be plain list 1, 2, 3, 4. So we have some cities. Srinagar, we have Delhi, we have Jammu. So it's going to be the list of cities, right? And we can have Goa, right? And these are called as names, right? And now what we can do, we can use lambda expressions, right, to basically count cities which start with we can say S, or we can say like this, we have SHIMLA, Shimla, right, and I can have Shillong, right? So we have cities like Shillong, we have Shimla, we have Delhi, and we have Srinagar, and we can have like whatever. Okay, let me show you these things. So for example, now if I have to search for cities whose names start with S, now how do you use lambda expressions, right, to basically loop through or to iterate through the names and find the Steve, whose name starts with S, right? So we can do that like this. So I can say count is equivalent to, I will say, now I'll call map. First I need to have the map. I need to get the map. So but I will apply, I will say I need to get the sum, right, and I need to get the sum of let's say about map, right, and I can apply LAMBDA. So I can apply lambda expression, and I'll show you separately how to use lambda expressions as well, right? So I'll show you, I'll make you understand about, I'll make you, each and everything about lambda expressions is going to be so easy for you to understand, right? So I'll just go through them once we finish this. Okay, so count is equal to lambda, and a lambda is same like we have already seen list comprehensions. So it's going to be same like list comprehension. So I can say S such that S. Now this S is basically a range variable that you have just declared, right? So that's why we say such that S dot. So I can say S dot starts with, right, and now I can say, right, S and H. Alright, so I want all the cities whose name starts with S dot H, right? But where are you going to find those names, right? So those names are here. So now out of these names, right, I need to find the cities whose name starts with SH, and then the count goes to this count variable. Right, so we are still going to get a bit of error right here, right, because we haven't defined a sum. So let me define this sum. So we had defined it earlier also. So I'll define a function. I call this sum, and this sum function takes two arguments, a and, let's say about a and c, or a and b. Now the function takes two arguments, and I say return back to the function a plus b. Now this is what my function sum does. So it's as easy as anything. Alright, so now I'm calling the same function and passing two parameters right here. Now I can say that I need to call sum, but I need to pass map, which is the lambda, right, lambda expression. So I can say lambda s such that s dot starts, right, with maybe starts with sh inside these names. So it should work. Alright, so let me make you understand first what this is, right, what a lambda expression does, so that you understand it completely. So let me delete it and let me keep this function, and let's get started with lambda expressions first. Before I get started with maps continued with lambda expression, we'll first learn lambda expressions. Now what is lambda expression? So take a note of these points, right? So I will take it here so that you can note it down. Lambda is a tool for building functions. It's a tool for building functions, right? It is similar to inline functions we can say of C. It's similar to inline functions of C. It's a tool for building functions. It's also called as, now this is very important, also called as So it's also called as anonymous function. Now what if I showed you the demonstration previously? What if I want to do the same with map function, but without even defining this function? Can I define this function in line without giving this function a name? That's what it's called. It's called as anonymous function. Means functions without names, right? So let me show you, expression. Let me show you some demonstration of lambda expression. Now if I say LAMBDA, so this is lambda, I'll say x such that x into 5, right? So now it is as simple as anything. So now the expression takes one argument x here, right? This expression takes one argument x. Now you can see this x here, right? And the lambda expression takes one argument, which is x. Now what do? You do x such that, so you are going to give to x whatever is x plus 5. For example, if x plus 5 or x multiplied by 5, right, if it is going to be 100, so this x will take 100, right? So this is called as range variable. You're just declaring this variable and you say x such that x into 5. So whatever is the result of x into 5 will be given back to this x, right? So the expression takes, that's why I told you that it takes one argument x. You have to supply one argument from here. Now similar to function, if the function takes one argument, so if I say, right, so this function right here, right, I'll say func define func or fun. Now if the func argument takes one argument, right, so this is the function fun, it takes one argument, that means we have to supply it, right? I can say fun and I'll say 10. Now this is what I am supplying it. Now this is your function, right? And it needs to have a body here as well, right? So this is the same with lambda expression. It takes one argument, you're supplying one argument, right? X multiplied by 5 will be applied. Now this x is going to be x multiplied by 5, right? So it is going to be the result of the expression, right, is x into 5, right? So I can say result of this lambda expression is x plus 5, as simple as anything. Now what does this lambda x have? X plus 5, as simple as anything. So if we call this expression as follows, right, so let me see this. Okay, let me call this as follows. So what is the result that we are going to get? 58. So let me see. Oh my god, we were getting this error earlier. We thought we were getting some error, right? So it was nothing, like we had no error at all. Okay, is everything now closed? Yeah, so let me, this time, why don't I go for a new file? Because there are too many comments right here, so I'll go for a new file. Right, and I will save this as, right, filters. Right, so I call this as filters. Right, okay. Now this is here, so let me run it. Fine. So okay. So we are not getting any error at all. So I'll say lambda is equal to x such that x into 5, right? So if I do something like that, ABC is equivalent to, so I'll say print AB. See, well, we know that what is x, then you'll say, sir, I need to get, a result of x. What is x? So we have not supplied any, x parameter, because you say x into 5, right? So I can say like this. Let me take it like this. And let me say x is equivalent to 100. Right? Or let me try and do it in some other way. If I do it like this, so I'll say lambda, right, is equivalent to x such that x into 5. So let me run it. Okay, fine. So you are going to, so the lambda expression is exhibiting properties of a function, right? So we know that it's going to exhibit properties of a function. So now I'll do the same, right here. So I will say, for example, I will say answer. Let me take it to, I'll say answer is equivalent to lambda of x such that x into 5, right? And I will say print, right, answer. Now you have to supply x. Now it takes one argument. You can now think it takes one argument, right? So this takes one argument, so I will say 2. So it's as good as function. So now you are going to get result which is 10 right here. So 5 into 2 is equivalent to 10. Now you have called this ans is equivalent to lambda and you're supplying this 2 as an argument. Now what happens? This 2 will go to this x. 5 into 2 is equivalent to 10 and this x will be 10, which is going to be returned to this. Now this works as a function, so there's nothing more different than a function than that this lambda expression does, right? It does as that of, or we can say as same as function, but the only difference is that function has a name and the lambda expression here does not have any name. So let me show you a few more examples to you. So let me close it down. Okay, let me show you a few more examples. So I'll say square is equal to lambda, right, of x such that x into x. Now I'll say what is this? Now x into x, that means this lambda expression takes 2 parameters. That means whenever you call this lambda expression, it takes 2 parameters, and multiplication of 2 parameters will go to this x and square is going to have the same. For example, if I say 10 into 10, I'll supply 10 as a first argument, 10 goes here. 10 as a second argument, this 10 goes here. 10 into 10 is 100, goes to this x, and this square is going to have 100, right? It depends on what value I supply. So let's supply, let's say cube. I'll create all. I'll create square, I will create cube, and in cube I will say LAMBDA lambda, right? So I will create here lambda of cube. I will say x such that x, now cube, right, into x, right? So it's going to be cube, and maybe add 3, right? So I am going to have different here. Okay, let me have add 3 here, add 3 numbers. I can say is equal LAMBDA. You can have this kind of lambda expression as well. You can say x comma y comma z. Now it's accepting 3 parameters. You're passing 3 parameter, right? And I can say x plus y plus z, right? So let me take all of them. Let me take all of them separately. So this is square lambda, this is cube, and let me print all of them, right, one by one. So I'll go to square and I'll say print. Now this accepts x into x. It's going to accept let's say about 1 parameter, which is here x only, right? So it accepts 1 parameter. You're going to add x 3 times. So I will say I'm supplying 5, right? Right, so I'll go ahead and supply 5 to SQU square, and I'll supply 5 here. Now let me print this. So we are getting 25. 5 5s are 25 is happening. You say 5 goes here, and 5 into 5, right, is basically given back to this square function. Now because I have to supply, we have this cube here, right? So because I have to supply cube as well, or no, because I have to supply only 1 parameter, right? So I will say print range variable, which is declared here. It's called as range variable. So I will supply range variable here, and which is 10, right? And it is going to be cube. So I am calling, what is soup? It's cube, right? Okay, I'm calling this cube function, right, which is a lambda expression. It's not a function, it's just a lambda expression, and I'm supplying 10. So where is this 10? This 10 goes here. Then what do you do to this 10? 10 into 10 into 10, and you are returning it back to this lambda function x, which means it's giving it back to this assignment. It's not comparison. So whatever is the result of this lambda will go to this, right, cube back, right? So let me run it now. Okay, you can see you are getting 1025 result here. Now you have to supply 3 because you are adding 3. So I can say, hey, wait a second, I need to print 3, and I will call, add 3. I'll call this function add 3, and I will supply x plus y plus z, which is going to be 3 numbers. So I'll have supply 2 plus 3 plus 4, right, or maybe 2 plus 3 plus 5, whatever you have to supply, and let me see the result of this. Now you can see you're getting 10, right? 5 plus, now you supply 2, 2 goes to x, 3 goes to y, 5 goes to z. Now x plus y plus z goes back to this lambda expression, is returned and stored in this add 3 function. That's very simple. As I said at the start of this lecture, that what is a lambda expression? It takes, right, basically it is, as I call it, it's a built-in tool, right? It is a tool for built-in functions, similar to C inline functions. It's also called as anonymous function in Python. That means Python has 2 tools for built-in functions. One is def, another is lambda. So I'll write it down here. Alright, so I'll just put it like this. So I can write it down here. So Python, it's better to say that Python has 2, maybe this piece of advice that I'm giving you, or the answer I'm giving you, may help you get good numbers in exams tomorrow, or maybe help you qualifying interview. Alright, so Python has 2 tools for building functions. What are those 2 tools for building functions? One is def and another is lambda. And if you think Java also introduced lambda expressions after Java 8. And Python has introduced in 3, maybe Python 2 also had some lambda expression. I'm not sure about that. But yeah, the latest version of Python 3.7 or 3.8 has good lambda expressions and good support for define and lambda expressions, both of them. Now, Python has 2 tools for building functions. One is anonymous function, which is lambda expression. Now, if someone tells you or asks you tomorrow, right, comes up and asks you, right, what is lambda expression, you get up and tell him it's a function, but the only difference is it's anonymous, a function without a name. Anonymous function. What is def? Def is a tool that we use to define a function, right, with a name. Only difference between lambda and def is that def takes a name which defines function with a name, and lambda does not take any name, right? All right. So this is how your lambda expression is going to work for you, right? I hope it's clear, right? We could compact our code by replacing the map function with a lambda, thus eliminating the need of sum function. We can see that as well. We have also used that sum function somewhere. You know that we already used, right? Okay, let me show you elimination of that sum function, right? Which we did yesterday. Alright, so I'll also show you that. Okay, let me close it down. Okay, now we know that we have some function here which returns. So we had yesterday L1. I said L1 is going to have a list with 1, 2, and 3 elements. L2 is also a list which is going to have 5, 6, and 7. And then I said L is equal to a list. I will say, hey, wait a second, x for, I say x for x, right, in, and then I created a function. I said I want to go in sum, and I want to apply 2 parameters to this map function, right? I say map them, right? And what do you want to map? In parallel, I'll say L1 and L2. Now what this sum function does, it returns the addition of two numbers, right? Is that what? Yeah, exactly, it's what it does. Now I can say print L. Now this is what we learned yesterday. Now you can see you're getting 6, 8 and 10, which is going to be, of course, 6, 5 plus 1, 6, 6 plus 2, 8, 7 plus 3, 10. So you're going to get 6. Now I want to use lambda expression and I want to eliminate the use of this function right here. Can we use lambda expression instead of this function sum right here? Yeah, we can eliminate. As I said, we could compact our code by replacing the map function with the lambda, thus eliminating the need of sum function. This also reduces the overhead of function calling. This also minimizes the memory usage of the program. It does magic, right? I'll show you how. Now instead of this map function, I'll say lambda. I'll call this lambda, and well, I do right here, right? And I can say lambda of a and b, just like this. How many arguments does it take? If it takes 3 arguments, you have to take 3, just like this, right? Now my lambda is taking 2 arguments, so I'll say AB such that, right now what do you want? AB is returning A plus B. Now whenever I call A and B, is going to return A and B, and it's as simple as anything. Then you call L1, L1 goes to A, L1's first element goes to A, because you're running map and you're running a loop, right? It's as simple as anything. Now delete this. Now you can still get 6, 8 and 10. And now has lambda expression here eliminated the use of built-in functions, use of user-defined functions? Yes, right? Exactly. You have to declare the variables you are going to accept. These are the parameters your lambda expression is accepting, and this is the result that you are returning back to the lambda function, right? And that's it. It's as simple as anything. So there's nothing harder logic here or bigger thing, right? It's basically it's a you can say it's a basic logic, right? Understanding this lambda expression, right? I have you understood map, you understood zip, or you understood lambda expression. We'll see. I'll create a complete video for lambda expressions, right, in detail. But you have to understand it's very simple lambda expression, so you don't have to be, it's very simple to understand that, right? Lambda expression. So I can say now we have another thing in Python. Please take a note. I repeat, take a note of these things, right? So this is for lambda expression. And yesterday I also gave you few notes regarding map and zip functions. So you got to take notes of all. And today what we are going to learn is, right, this, and this. So we are going to learn filter function, right? What is filter? Filter offers an elegant way of, or we can say, to filter out all the elements of a sequence, right? It is once we follow sequence for which the functions or function returns true. It returns an iterable, yes, just like, let me show you a demonstration, then write down all the explanations and definitions, right? So let me show you a demo. If I say I define a function, I call it even, and it takes one parameter, which is going to be a, and I will say even number is a. I'll say if a divided by 2 is equivalent to 0, then what you got to do is return true, right? Okay. Else what you got to do is return false, right? So now whenever you call this function even, it's going to return even numbers, right? So whenever you call this function, you have to supply a number, and if that number divided by 2 or modulus 2, right, the remainder is 0, then return true, otherwise it's going to return false. So true has a capital T and false has a capital F. So let me run it. Yeah, unexpected indent somewhere. Where? Okay, here maybe. Alright, so just do it again. Yeah, it's absolutely fine now. Alright, if else. Okay, if a divided by 2 is equivalent to 0, it's an assignment. No, it's not an assignment. It is comparison. It's logical comparison. All right. So if a divided by 2, return true, else return false. There should not be any error, right? Maybe we have to just delete it. What indent problems? Why? Why do we have indentation problems? Now this should not be okay. So let me say it is like this. Just a moment, I'm getting some indentation errors. Still expecting an indented block. If I say pass, alright, so it's working fine. So now I had to find a function. So I will say if a modulus, right, 2 is equivalent to 0, then you say return true, right? So it's just true, return true. Right, it's fine now. Else you return false. I don't know what was wrong earlier. Yeah, it's absolutely fine now. Now what I want to do is, let me say I have a list L1, and this list it has 1, 2, 3, 4, 5, 6, 1, 2, 3, or let's say we have 1, 2, 3, 8, 6, 11, and 7. So this list has how many elements? 1, 2, 3, 4, 5, 6, 7. 7 elements, so that's understood. Right? And even is the function name. So let me apply L is equal to list comprehension. So I'll say X for X in. Now let us see. If I say I want to apply X for X in, right, and I say I need to get filter. Now see this of even, because filter takes here, the true and the false now, and I will supply this L1. Just like we did with map, we're doing it with filter. So let me see. Yeah. Now if I say print L, so you are going to get all the even numbers right here. So you can say 2, 8, and 6, right? So the three even numbers 2, 8, and 6, which are divisible by 2, 2, 2, 2, 2, 4, right? So now what is this filter doing, right? You can see this here, selects even values from the list here, we know that, right? Even is a function name, we know that this function, it's a function name, and L1 is the parameter that we are going to give to this function, and we are calling this function in a loop, right? And this is how your filter is going to return an iterable. As I said, this filter offers an elegant way to filter out all the elements of a sequence. Now what is this? Is it sequence? Yes, we are applying sequence here, right? For which any function returns true. So now this filter is going to take only true, not false. Now if I do map here, so what is map going to return me? Map is returning me false, true, true, true. Now where is false? False. 1 is false, it is not an even number. 2 is true. Now let me take this, copy this, and let me take it here so that you know. Now this is what map returns. It returns false. Okay. True. 2 is divisible by 2. Right. 3rd is false. 4th is true. 8 is divisible. Right. 6 is also divisible, and then false. 11 is not, and 7 is not. Now if you want to get only the numbers, if you want true only, you don't want to get false, right? Because you want to get element of sequences for which the function of the function returns true. So I will say filter. So it's now going to get only, right? And it's not going to return true, it's going to return the numbers. Now map returns true or false, it returns the return type of the function, and here filter returns the number basically. If you see, this is the difference between filter and maps. If you are aware of map applies to a function to every element inputs iterable collections, right? So it returns an iterable, right? And here it also returns an iterable. But one of the best function definitions, or we can say differences, is that it returns. Now if I say return 1 and return 0, so we can do this as well. Now what do I get? I get same 2, 8 and 6. 1 means true, 0 means false, right? You can see this right here. So if I say return 0, 0, I get nothing at all, right? But if I do 1, return 1, so that means return true. Always remember 1 is true, 0 is false, right? Even if it's integer or boolean, 1 is always true and 0 is always. Let me show you some other Fibonacci series, right? Or maybe it's sufficient for you to understand, right? This filter, right? So I'll write the definition of filter before you, and it's very easy. Once you get aware of this filter, you're not going to get 100% in the beginning, but yeah, once you are aware of about this filter, you're going to get it like a pro. So it's not a big thing. So it offers an elegant way to filter out all the elements of a sequence, right? All right. So you have any sequence, you want to filter out elements, right, for which the function returns true. As simple as anything. You want to filter out all the elements of a sequence for which the function returns true. So this is the function. It is returning true whenever you go and give something to a, and whenever that a divided by 2 returns 0, right? If it is divisible by 2, any number that you're giving, if it is divisible by 2, you return true or you return false. It's as good as returning true or false. 1 and 0 also means return true, 0 means return false. Now you are going to get the numbers where your function has returned true, for which the function returns true. That's how I've written it here, right? For which this function returns true. So I'll write function returns true. First you pass 1. Function returns false. You're not going to get this. Filter is not going to take it. For 2 it's returning true. Filter is going to take capture 2. For 2 it's coming filter, right, true. And for 8 it's coming true. For 6 it's coming true. So it's going to show 2, 8 and 6, and that's what this does. 2, 8 and 6 is practically and physically shown, right? Hope you're getting it, and if you are able to understand it in a nice way, right? So I must congratulate you, you're getting it. Even if you're getting 50-60%, but because once we start doing it practically, you are going to get it completely all right? So you're not going to bother about things that you're not getting. But yeah, if you're getting the logic right, the main thing is, and the best thing is, that we have to understand the logic behind things. What is the logic behind different things that we are doing, right? I'll give you Lambda Expressions session, right, completely, and it's not a big thing, right? So it's a very small thing. For example, now let me close it down. Alright, so let me close it down for you just for 5 minutes, right? And let me go ahead and copy this, right? Alright, so let me show you this lambda fraction. This lambda accepts x, y and z. I can see username, it accepts password, right, and it accepts something. So it can be anything, and then you can manipulate them here, whatever you want to do. If you want to go to the function, you can go to the function. If you want to have another lambda here, you can have another lambda here, right? So if you want anything that you want to do with the function, right, and it's very faster than a function, right? It's basically more faster than function because it's a function without any name. That's why we call them as anonymous functions, because they don't have any names, right? So here we can pass anything, username, password, and you can say, for example, we have get full name, right? So I can say get full name takes f name and it takes l name, and now what I do, I return back to this lambda function f name, right, plus a bit of space, and then I say plus L name. So I return, in concatenation, I return this back to the function. So it's as simple as anything. So I can say print get full name, alright, or we can say, let's say about, I'll say full name. Instead of a function, it's basically same thing. So I can say print, or you can say print get full name. If you want to get that IntelliSense, you can press keep the control key pressed and then press space bar. You are going to get that, right? I'll show you again. I say print and now I type GET. Now if you want to get it through IntelliSense, get full name, hold down the control key, keep it pressed and press the space bar. You are going to get it. Get full name. So I'll say print get full name, and I have to supply two arguments here, right? Just like we were supplying it here. Okay, it's as simple as anything. So I'll supply FAHIM and I supply KHAN. So I am going to get Fahim Khan. So it's going to return me the full name, which is Fahim Khan. So that's what we do with the function, right? For example, had this been a function, right, I can say define get full name, and this function takes two parameters, f name and l name. So for example, if it takes two parameters, so I can do something like this. I can say return back to the function f name plus l name, but yeah, I want some gap in between, or I want some space in between both the functions. So I'll say alright, so return it back to the function and now call the function. So you can see you will get the same result, Fahim Khan. The only difference is there you were calling a function without any name. It was an anonymous function, and here you'll say why creating an anonymous function then? It's not necessary. You can print this anonymously right here. You can say that I'm printing this anonymously. You can just print this anonymously as well, right? Okay, so now you can see you're getting the same result, Fahim. Let me take a look at timing. So timings, we're already at 42. Okay, let me show you a few. Alright, then I had some sore throat. It happens in Ramadan. Alright, it is because you keep on frequently speaking, right? Okay, let me continue with Lambda Expressions more, right? And we'll wind up with today's session with Lambda Expressions, right? And maybe someone has turned on my narrator. I don't know who has turned on the narrator. Alright, and Lambda Expressions are, there are many different things in Lambda Expressions that we can do, and out of those many things I'll show you formatting, right, and different things. So let me say x is equivalent to lambda, right, of a such that a plus 10. You can say that, okay, I need plus 10 of everything that I supply. You can say immediately print the lambda expression, right, which is x, and supply 5. So now this is how you call an anonymous function, right? Okay, now you are getting the result in here, right? So I'll say print x plus 5, right? And you're getting 15, all right? You can say 5 plus 10 is equal to 15. So the answer is 15, all right? And you can do this as well. You can supply many A, B, and C, all right? In that matter, you have to supply 3. 5 plus 10 plus 5, which is going to be A plus B plus C. So I can say A plus B plus C. So that way you are going to get 20. So now you can see you get 20 in the answer right here. Okay, let me show you more complex thing using this lambda expression. For example, I've shown you full name. I'll show you full name again. Full name. I'll say full name is equivalent to lambda, right? So now we'll pass arguments right here, and those arguments are like let's say about f name and l name, but I want to return a formatted string. So you can say now you can return a formatted string. You can say full name, right, is equivalent to, right, this, right. You can do this as well, all right. And last name is equivalent to this. Okay, so now this is how you can do this as well. You're okay, returning the formatted string right here. Okay, now this is your lambda expression and you can say full, or you can say print full name, and you have to supply arguments as 1 and 2. So you have applied 2 arguments, and I can say now run it, right. We have an error right here, just a moment. Full name, we have to apply first name and last name right here. All right, and just a moment. Print full name. Why aren't we getting this? Well, I forgot to close the literal here. I did not close the quote. Now you are getting full name. You can clearly see the answer here, right? Full name is equal to Fahim and last name is equivalent to Khan. So this is how you apply lambda expressions, right? And in short, they are the functions without names. That's why we call them as anonymous functions. Or you can even do this in a single quote. I'll show you another way of formatting, right? We can say full name. Now you have to get the full name, right? So I'll say full name is equivalent to, now I'll join both of them, right? Say F name, right? And I will say L name, all right? So that way we are going to get the full name as well. All right, so I'll say F name and L name. So this is how you are going to get full name. Full name is equivalent to Fahim Khan. Or you can say dot title. You can apply the title argument. So title is going to return the same. So now title is going to return the same, right? Whatever is in this. So F name dot title. So F name has Fahim title and L name has Khan title. So you'll say full name is equivalent to, or you can have this full name. You can get full name is Fahim Khan. So this is how lambda expressions work. Do practice for lambda expressions. The next video is going to be completely of lambda expressions, right? And in next video we are going to learn A to Z of lambda expressions. You call them lambda expressions, or you may call them as lambda functions. And let me congratulate once again. Congratulations from my side for coming so hard. And it is going to be fun. Just after 2 or 3 classes, you will start getting that real essence of programming and real essence of scripting with Python. The moment we start object oriented, you are going to love it. You are going to, be really happy for, for choosing this course, and you're going to appreciate your decision for going ahead with Python, all right? And you're no longer beginners, and once again, congratulations. Practice hard, practice for zip, it's very important. Map is important, and similarly lambda is important, and filter is also important. So all 5 functions are with you. Go and practice them hard, and I'll see you in the next video tomorrow, inshallah. Till then, wish you good luck. Bye bye, take care.